Now we're going to do a couple of practice problems here. This first practice problem says Molly is standing at the top of Mount Everest, which has an elevation of 29,029 feet. Her eyes are 5 feet above ground level. The radius of the Earth is approximately 3,960 miles. How far can Molly see on the horizon? So, what we need to remember, this right here is going to be a tangent because it's going to intersect the Earth just at this point right here. And a tangent and a radius are going to make a right angle. Okay? And so, what we need to do, we've got a right angle. So what I'm going to do here is I'm just going to draw my right triangle out here over to the side. So it just makes life a little bit easier. It says the radius is approximately 3960. So here's a radius right here. And then here's 3960 right here also. So this part is going to be 3960. This part is going to be 29029. So this part right here is going to be 29029. And then it says Molly is standing, her eyes are 5 feet above ground level. So we've got to add 5 feet to that because Molly is 5 feet, or her eyes are 5 feet above that. So if I add up all three of these numbers right here, that'll give me the hypotenuse. Oh, and it looks like I forgot my 0 right here. So let's add up all three of these numbers. So I've got 3,960 plus 29029 plus the 5 extra feet. So this is 32,994. And I want to know how far she can see. So this right here is what I'm looking for. Now I can just use Pythagorean theorem. So circle problems sometimes seem very complicated, but when we actually look at the different pieces, they tend to be a lot easier than we make them. So I know my x is going to be my first, and plus my 3960 squared equals 32,994 squared. X squared is going to stay the same. 3960 squared. Ooh, that's a big number. 15681,600. I have a feeling this next one's going to be even bigger. And it is 108860436. Now I'm going to subtract this from this. So x squared equals 10729224336. I can square root that number, and I get 32,755 miles. So she can see pretty far when she is up on the top of Mount Everest. Now let's look at this next problem down here. It says when you are able to see past the buildings and hills or mountains, when you can look all the way to the horizon, how far is that? You can use Pythagorean theorem to help you tell. Imagine you are standing on the surface of the earth and you have a height of h. The distance to the horizon is given by d in the diagram shown, and r is the radius of the earth. Using your height, create a formula you can use to determine how far away the horizon is. So we want to know d. So we would know that r squared plus d squared equals r plus h squared. Let's see. And we want to solve for h. So this, or do we want to solve for d? We want to know how far. So we want to know the distance. We want to solve for d right here. So we would just drop this down. And this is a lot of theoretical algebra. And it's kind of hard because we do not actually have numbers. If you remember, r plus h squared is just going to be r plus h times r plus h. And we're going to do, I know some of you have learned the box method. Some of you have learned FOIL. When I was in school, it was FOIL, but I'll go ahead and do the box method. I think that's what Frisco kind of does. So we have r and we have h here, and r and h here. R times r, r squared. Then we have r, h, and then h squared right there. So we would have r squared plus 2rh plus h squared. Now I've got r squared on both sides, so those cancel out. So d squared equals 2rh plus h squared. I'm going to square root the whole thing now. So d equals the square root of 2rh plus h squared. I think that is, as far as I can simplify it, this one's kind of tough. It's just trying to figure out in terms of, you know, the radius and the height, what is the distance of the horizon?